Lesson 67 deals again with finding areas, but this time we're going to have areas involving functions of y. So we are going to have our equations or relations written out in x equals something with y in it rather than y equals form. So our first example, we're going to show why this is sometimes helpful. So here we have x equals 1 minus y squared. It's a parabola. It's facing to the left, and it's shifted to the right 1. So here's the parabola. And in order to find the area between the curve and the y-axis, using our old way, what we would have to do is split it up into two parts. We could solve for y. And when you take the square root of both sides, you get the plus part and the minus part. And then we could integrate from 0 to 1 and then do another integral for this one. So what we want to do is be able to simplify the process. So instead of solving for y and doing all of that and splitting them into two parts, we can actually think of this as x equals 1 minus y squared, and we can integrate this time in terms of y. So what we want to do is, same idea, we're going to integrate, but remember, this is in terms of y. And so as we look at this, we're going to integrate, and we can figure out that this crosses at -1 and 1. So we're going to integrate from -1 to 1 of our function 1 minus y squared dy. And that'll find us the area between the curve and the y-axis. So before we were looking at area between a curve and the x-axis. And then we just integrate. So we have y minus 1/3 y cubed. Evaluated from -1 to 1. Plugging in 1, we get 1 minus 1 cubed is 1 times 1/3, so 1 minus 1/3. And then we want to subtract when we put in -1, so we get -1 minus -1/3. Simplifying this, this is 2/3 minus -1 plus 1/3 minus -2/3. So we have 2/3 plus 2/3, which is 4/3. And that is the area. Had some equal signs in here. So 4/3 units squared. So we come to this next one. It says find the area of the region completely bounded by the graphs of x equals 3 minus y squared and y equals x minus 1. So I do have the graphs here, but let's just think about this first. It says find the area of the region. Looking at this next slide, it says find the area of the region completely bounded by the graphs of x equals 3 minus y squared and y equals x minus 1. What we want to do to start with is just have a quick sketch of this to see what we're dealing with. We know this one is a parabola. It's opening to the left because it's a -y squared and it's moved right 3. So we're going to have this parabola moved right 3. And it looks something like this. And then we have a line, y equals x minus 1. So y-intercept of -1, slope of 1. So we have this line right here. So we want to find the area bounded by those two curves. Looks like it's going to be in here. And what we can do here is we could try to split this into things having to do with dx, but it's going to be a lot easier to look at this in terms of dy and do the parabola, which is the one to the further right, subtract the line from that when we integrate. So this is helpful in these cases to be able to integrate in terms of y. Well, in order to do this, we need to find our points here. And really, we need the y values. We don't need the x values. So we would want to solve an equation that has to do with y. So it looks like maybe what we can do here is some substitution. We can take this, because x equals 3 minus y squared, and put it in for x. And so we have y equals 3 minus y squared, and then minus 1. So we put this in for x. Now let's solve for y. So let's get everything to one side. So we'll have y squared. We'll add y squared to both sides. We still have plus y. And then we have a 2. 3 minus 1 is 2. So we'll subtract 2 from both sides. That's equal to 0. And the y values where they intersect, we can find that by factoring. We got y plus 2 and y minus 1 equals 0. So y equals -2 or 1. So those are going to be our values that we'll use for our definite integral, because we're going to integrate in terms of y. So let's do that. So we're going to integrate. We're going to go from -2 to 1. So this y value is a -2, and this value is a 1. So we're integrating from -2 to 1, and we want to do the rightmost one, which is the parabola. So we'll do 3 minus y squared, and we'll subtract the line. Now remember, we're doing this in terms of y, so we need to go ahead and solve for x here. So if we add 1 to both sides, we'll get x equals y plus 1. And so we're doing the parabola minus the line, y plus 1, dy. So let's just simplify this quickly. -2 to 1. We're going to have a -y squared. I'm going to go ahead and put it in descending order. -y squared. This will distribute, so I'll have minus y. This will distribute, so we would have a -1, and 3 minus 1 is 2. So we add 2 in here, and we integrate. So if we integrate this, we would get -1/3 y cubed minus 1/2 y squared plus 2y. And we are integrating from -2 to 1. We'll plug in 1. So plugging in 1, 1 cubed is just 1, so we got -1/3. Y squared is 1, so we have minus y half, 1/2. And we have, putting a 1 in there, we get plus 2. And we want to subtract what we get when we put in -2. So we got -1/3. Putting -2 in there is -8, so times -8. And then we have minus 1/2. Putting -2 in there, -2 squared is 4, so times 4. And then plus 2 times -2 is -4. This is going to be -1/3, and -1/2 is -5/6, plus 2 is 1 1/6. And we are going to subtract what we get over here. Negative times a negative is positive, so this is 8/3 minus 2 minus 4. So we have 1 1/6 minus, well, this is 2 2/3. So we got -6 plus 2 2/3 gives us -3 1/3. But we are subtracting that, so here we go. 1 1/6 plus 3 1/3 is going to be 4 1/2. So the area between these two curves is 4.5 units squared. And you can use y values to integrate to help find the area between two curves.